these metals can replace hydrogen in cold water. So this would be if you saw H2O with a little L out beside it. So that would mean liquid form. The next one can replace hydrogen from steam. So this would be H2O and it'd have a little G out beside it for gas. This one, all the way from here to here, can replace hydrogen from an acid. So if you have H and Cl connected, that would be an acid. And then from here to here, we have react with oxygen to form oxides, which you're not going to really have to look at as much. Now, the halogens work the same way. There's just only 4 of them that actually react with things. So fluorine can replace anything. Iodine can replace nothing. Okay? So that's how we use our...
Is that chlorine?
Activity series. Fluorine can replace any of them, but iodine can replace none of them. Yes. All right, so let's look at our single replacements then. Our first one is a metal-metal replacement. So A plus BC gives me AC plus B. Right? Metal-metal means that we're replacing the 2 positive pieces. So that means that A is positive and B is positive, so that's why they're switching places. So this would be like if we had calcium plus aluminum oxide. Since calcium's by itself, the only question that we need to ask is it diatomic? So is calcium diatomic? No. So it would just be Ca plus. Alright, then aluminum oxide, so we would need to figure out what that formula was. So aluminum is Al, and what is its oxidation number? Three. And oxide is O, and its oxidation is 2 negative. So how would I write that compound? Good. Al2O3. Alright, so now what I want to do is figure out A and C and B. So one of the easy ways to do this is to have your pieces, I like to write them right above the elements. So let's go ahead and fill calcium in while we've got it. Calcium is what oxidation number? 2. Alright, and then I'm going to label these. So this one's by itself, so it's A. Then aluminum is in the compound and it's the positive one, so it must be B, and oxide must be C. So now we can easily tell what 2 things we're putting together. So on the flip side, we're putting A together, so that would be Ca plus 2 plus C, which is right here, and C is O negative 2. So how would I write that compound? Plus B, and B is aluminum, and if I write an element by itself, the only question I ask is it diatomic? Is aluminum diatomic? No. So this would just be Al. Alright, then we need to balance it. So I've got 2 aluminums here. I got 1 aluminum here. So I'm going to multiply that one by 2. I got 3 oxygens here. I got 1 oxygen here. So I'm going to multiply that oxygen by 3. That gives me 3 calciums. So I'll multiply calcium by 3 as well. Alright, and then we're going to check our activity series to make sure that the reaction can actually go. So calcium is replacing aluminum. So here's calcium and here is aluminum. So calcium is higher than aluminum, so my reaction is good.
So that's just how you check yourself.
Well, I mean, you can form the compounds, but then it could, you know what I mean? Like, because you could write them on paper, but it doesn't mean that in real life that they can actually form. Alright, let's say we have potassium plus zinc chloride. Alright, potassium plus zinc chloride. Alright, so potassium is by itself. This is going to be my A. Zinc is the metal, chloride the non-metal. So I've got my things there. Potassium, how would I write it?
Okay.
Yep, just K. Alright, then I'm looking at zinc chloride. What is zinc's oxidation number? 2. And chlorine's is -1. So how would I write that one?
Z and CO2.
Good. Alright, so now I'm going to go back and just fill in calcium so I have it. Calcium is K,
You mean
potassium, yes. Is K what? What charge? 1. Alright, and so now we're forming A and C. So A is potassium, C is chlorine. So how would I write that compound? KCl. Plus B. B is zinc. Is zinc diatomic? No. Alright. Can K replace zinc?
Yes.
Yes, it can. So this equation is good. And now all I need to do is balance it. So I've got 2 chlorines here. So I multiply this one by 2. That gives me 2 potassiums there. Multiply potassium by 2. And I got 1 of each zinc. Alright, type A single replacements. Let's look at type B. So B is an active metal, replaces hydrogen from water. So this one is a metal plus H2O. Alright, and alpha side H2O, it's either going to tell you that it's a gas or it's a liquid. Alright, you need to know that because you've got to know which part of the activity series we're looking at. Alright, and it breaks down to give us metal hydroxide plus H2. So this is the part we're going to have to form. H2 is just going to always be a second product that is attached. Alright?
I'm so sleepy. I don't know.
So let's say we have the first part of this one is kind of simple. Is sodium diatomic? No. So it's just Na plus H2O. And I'm going to keep the fact that H2O is a liquid there. Alright, so on the flip side, we're creating a metal plus hydroxide. So what is the metal in my compound? Sodium. So that's going to be Na, and what oxidation does sodium have? Yes. And then I'm combining it with hydroxide. So that's OH, and what oxidation does that have? -1. So how will I write that compound? Plus, what's my other product? Hydrogen. So we just write that bad boy in. Alright? Now, we can leave H2O as H2O, or we might want to rewrite it as what? HOH. So I'm going to rewrite it as HOH to make it a little easier to see. So I've got 2 hydrogens, and I only have 1 hydrogen here. So I'm going to multiply that one by 2. That's going to give me 2 OHs. So I'm going to multiply OH by 2 over here. That's going to give me 2 sodiums. So I'm going to multiply sodium by 2 over there. Alright, let's make sure that this reaction can take place. I'm looking for sodium to be higher than the hydrogen of water, which means we're looking at that shortest line. This white. Yes. Uh-huh. Sure. Monet, Ochelet, Miss Davis, C. And the council thing. Alright, so here's sodium. Here is the line where the metal can replace hydrogen in water. So sodium just barely makes it, but it made it above that line, which means the reaction can take place. Alright, let's say we have nickel plus H2O as gas.
He said the gas.
Mm-hmm. Alright, and if you want to check the activity series first, we could do that, and then you would know whether or not you even had to do the problem. So we're looking at nickel. Nickel is Ni, right? So if we're looking at the activity series, we're replacing hydrogen from a gas this time, which means we're looking at this line right here. Is nickel above this line? No. So if nickel is below the line, then that means that the reaction cannot take place. And so if you check your activity series first, then you can just write in no reaction. Let's say you had completed the reaction and then checked the activity series. That's fine. So if you end up with the whole problem written out and then you realize the reaction can't take place, all you do to signify that is over here on the products, you're just going to put an X across them. And that's going to show me those that's what the reaction